Vinod, in the digitalization session here at CERAWeek on the impact of digitalization in the energy industry, the topic of retaining knowledge, reskilling, upskilling was a theme, constant theme. You mentioned fit for future. What is that?
Yeah, I think it's, from when we talk about transformation and you talk about transitions, what's really important is that we have to give everybody a fair chance to be able to also be part of this transformation journey. Mm-hmm. So in other words, you don't want to leave anyone behind as things, as technologies, as markets transform and as companies transform. So for us as Siemens Energy, one of our, if not the most important ingredient of our success is our people, right? So Fit for Future is a program that was kicked off in one of our divisions, the generation division, where it was a division that had to start transforming itself from the inside because of the changes taking place from the market perspective. So Fit for Future is a strategic workforce development program, right, where you really look at what are the current capabilities of your workforce, like what are the engineering skills, the manufacturing capabilities, the sales and marketing capabilities that the people in the organization have today. Mm-hmm. And then you strategically look out 5 years, 10 years to see what are the skills of tomorrow. So for example, do we shift more from mechanical engineering to a mix of mechanical and electrical engineering, or a mix of mechanical and chemical engineering, mm-hmm, or we look at digital engineering and capabilities around software? Do even the managers understand the language of digital? Do managers understand what does it mean to be a digital business or develop a digital business model? Mm-hmm. So Fit for Future is a program that has now taken this broad topic of workforce upskilling, mm-hmm, breaking it down into some strategic areas of focus, and then creating the appropriate training programs and the educational programs and the on-the-job and offline training and learning sessions to be able to get the workforce also having the opportunity to compete in the marketplace of tomorrow. And that's why we call it Fit for Future, because you really try to make the people in your organization and then by default, the organization ready and fit for the future.
Now, another thing you mentioned, you're the Chief Technology and Strategy Officer for Siemens Energy, and you've got a few reverse mentors.
Yeah, I think one of the biggest challenges in this job, especially the CTO job, is that there is so much new technology, new ideas constantly coming up around the world. And innovation is really something that is a global trend. Mm-hmm. So it's almost impossible for a person to stay relevant in the times as times change unless you find new sources of input, new sources of information, new sources of education. So for me, what the reverse mentorship does is it just changes the paradigm. So normally, when I'm a mentor, I'm usually mentoring people based on my experience. A reverse mentor is usually somebody who is demographically, generationally at a different stage in their life. Yeah. They are usually in their 20s or 30s. They see the world differently. They are much more digitally savvy. They are much more technologically adept in areas that I'm not. And I actually use them to help me also learn and understand.
They mentor you?
Yeah, they mentor me. And I go into these meetings with my questions. And it's very fascinating because the way a 20-year-old or a 30-year-old sees the world is extremely different from the world I grew up in. And so for me, it's about really then also making sure that I may not be able to do everything they say or even possibly learn as much as I would like to. But the point is I go from a state of what I would call unconscious incompetence to maybe conscious incompetence or in some cases conscious competence. And that's where for me reverse mentoring is so relevant and so valuable.
Now you mentioned the pace of innovation is not slowing down, and here at CERAWeek and down in the Agora, many people would say, look, we have enough bankable technology to just go do stuff today, as you hear. We don't need all the latest and great or wait for something, but yet innovation is not slowing down. So digitalization, chemistry, mechanical engineering, material science. Any particular thing that you kind of seen that you're keeping an eye out for?
I think, there are different building blocks and it depends on what level of granularity you go down to, right? So If I would start maybe on the upper level, let's talk about a technology as a system. So when we talk about solar or wind or nuclear, that's a technology of, at the highest level of aggregation.
Right.
Within that, you have many different technology fields and disciplines, as you said, materials, electronics, thermal heat transfer, and design, and all of that. So for me, if I would kind of approach this from both sides, one is we have all the technology we would need to make us much further along in terms of net zero. Over there, the challenge is scalability, right? So
Sure.
a lot what you heard in CERAWeek is how do we increase the speed of scaling up very promising technologies. In that regard, when I look in the future from a top-down perspective, the areas that I feel really excited about in the, let's say, 10-plus year horizon,
Right.
is all that will happen around fusion. I think nuclear fusion is an area that is progressing dramatically fast due to the way startups are bringing in a lot of the knowledge from the past and approaching the development of nuclear technology from an innovation perspective very different. So nuclear fusion is something that I'm really keen on seeing how that develops. The second is large utility scale storage.
Okay.
We are looking at some topics, for example, around redox flow batteries and so forth, which we believe could be the long-term solution for utility scale storage. The third is, again, continuing to develop the next generation of materials and technologies around electrolysis, solar PV, and there are some very exciting new developments taking place where the efficiency of solar will improve and increase so that the amount of land mass and the amount of material required will go down, because I think as we think about these renewable technologies, we also have to be very mindful of the cost of sustainability and manufacturing, because we just can't, just because the solar energy and wind energy is free, we have to find ways to improve the energy density of the technology. So that's the top-down view. Bottom-up view, I think there is a lot of interesting stuff happening in materials. As you think about the new material chemistries, nanotechnology, I think that's going to be a game changer in the next 10 plus years. Second is around additive manufacturing. I still think that we are just touching the surface of the potential of additive manufacturing. I think that's going to be a game changer. I think as computing evolves towards quantum computing and the next generation of computational capabilities, I think that will bring a whole different flow.
Changes the paradigm for...
Changes the paradigm completely. And I think the last would be more around design methods and the way you kind of pull different technologies and the ability to co-innovate or co-create. It's more of a, it's not a hard skill per se or a hard discipline, but I do believe today we are still limiting ourselves in innovation space because we are not working across disciplines.
We're siloed. It's materials, it's engineering, it's IT.
Exactly, it's still relatively siloed. And I do see it actually improving, but I think over there also the way we work together, the way startups can work with large corporations, the way large corporations can work with universities, the way universities can work with startups or also financial and economic and governmental institutions. I think there's a whole host of potential there that we can really bring to bear, and the sum of the parts then becomes much greater than the arithmetic sum.
Interesting times ahead. It's just we need to get it done faster.
We get it done faster, the world needs it, and 800 million people today still need it. So we have to find a way to really scale this up and get us to net zero much faster. I mean, just one last point to kind of put the challenge in context. In the last 30, 40 years or so, the amount of energy coming from hydrocarbons has only reduced by a few single-digit percent points. And the next 30 years, for us to be able to achieve our net zero targets, the amount of energy coming from hydrocarbons needs to be reduced by a factor of almost 10 times that. So the rate of change is absolutely needs to be exponentially greater to be able to achieve net zero. And yeah, so I think it's an exciting space. I think from a energy market, the need in the market, the opportunity to have a net positive impact on climate, the innovation capabilities and the scale, I think that makes Siemens Energy one of the only companies that can actually play a relevant and noticeable role in this transition. So I'm super excited to be here.
Oh, hey, I wish you well. It's an interesting ride ahead.
Absolutely. Thank you.
Thanks a lot.